Hello dear students of class 11 science, hope you all are doing well. I am Nabi Hassan, your chemistry teacher, and today to this video I am going to start a new chapter. The name of the chapter is the S-block elements. Now first of all, what is S-block elements? Now when you see the periodic table, you'll find there are 4 blocks: S, P, D and F. Now what are these blocks? Now these elements are classified based on the last electron. Now let us take an example. Say carbon, atomic number is 6. So if you write the electronic configuration is 1s2, 2s2, 2p2. Now if you check the last electron enters in p orbital. So carbon belongs to p block. So we check the element, the electronic configuration. In the electronic configuration, if the last electron enters in s orbital, the element will be kept in s block. If it enters in p orbital, the element will be kept in p block. If it enters in d orbital, d block, and if it is f block element. So from here, I'm sure you have got an idea what is s block element. So the elements where the last electron enters in s orbital are known as s block elements. Example, you can take lithium, atomic number 3. Its electronic configuration is 1s2, 2s1. So you can see the last electron enters in s orbital. So therefore, lithium is s block element. Now under s block elements, there are 2 groups. Group 1 and group 2. Now why only 2 groups? Now if you check the capacity of s orbital can take maximum 2 electrons. Can take maximum 2 electrons. That's why under s block you have 2 groups. That is group 1 and group 2. If you check p orbital, the capacity of p orbital is 6 electrons. So that's why under p block you'll have 6 groups. That is group 13 to group 18. D orbital capacity is 10 electrons. So that's why under D block you have 10 groups. Group 3 to group 12. So now this group 1 and group 2. The elements of group 1 are lithium, sodium, potassium, rubidium, cesium and francium. The elements of group 2 are beryllium, magnesium, calcium, strontium, barium and radium. Now these elements of group 1 together they are known as alkali metals or alkali metal elements. Whereas the elements of group 2 they are known as alkaline earth metal elements. Now alkali metals. Now why they are known as alkali metal? Because if you prepare the solution of alkali metal in water, that means the aqueous medium solution is alkaline in nature. Alkaline means basic. So they are alkaline in nature, that's why they are known as alkali metal. Group 2 metals Their solution is also alkaline in nature. So they are known as alkaline. And they are also found deep inside the earth crust. That's why they are known as alkaline earth metal. So group 1, alkali metal. Group 2, alkaline earth metal. So we have to study group 1 and group 2. We have to study their properties. We have to study their electronic configuration, ionization enthalpy. Then we have to study hydration enthalpy. We have to study physical properties, chemical properties for both group 1 and group 2. So we start with the group 1 elements. So we'll start with the electronic configuration. So you have lithium, sodium, potassium, rubidium, and cesium. Lithium atomic number is 3. You can take francium also. Sodium atomic number is 11. Potassium is 19. Rubidium is 37. Cesium is 55. Francium is 87. Now there is a simple trick to remember the atomic numbers of the elements of group 1. There is this number called magic number, and it's 2, 8, 8, 18, 18, 32, 32. It's also written as 2, 8, 18, 32. Now, lithium with atomic number 3 will be here. Now, these are nothing but the number of elements in the period. This is first period, you have 2 elements. Second, you have 8. Third, you have 8. Fourth, you have 18. Fifth, you have 18. Sixth, you have 32. Seventh, also you have 32. So lithium with atomic number 3 is in the second period. Sodium is in the third period. Potassium, fourth, and so on. Now, the atomic number of sodium will be lithium. The atomic number of lithium plus 8. So sodium will be lithium 3 plus 8, 11. Similarly, potassium atomic number will be atomic number of sodium plus 8, that is 19. For rubidium, the atomic number will be 19 plus 18, 37. For cesium, the atomic number will be 37 plus 18, 55. For francium, the atomic number will be 55 plus 32, that is 87. Let us write the electronic configuration of the alkali metals. So lithium, atomic number 3, that means there are 3 electrons. Electronic configuration is 1s2, 2s1. Using inert gas, we can write the electronic configuration. We know the inert gases: helium, neon, argon, krypton, xenon, and radon. Helium atomic number is 2, neon 10, argon 18. Can use the same magic number. Potassium 18 plus 18, 36. Xenon 36 plus 18, 54. Radon 54 plus 32, 86. So for lithium, we can use the inert gas, that is helium. Helium atomic number is 2, so 1 is 2. So in place of this, we'll write helium, that is He. So helium 2s1. Now here, this 2 is the cell number, and this will be helpful in studying the atomic radii and ionic radii. Next, for sodium is 1s2, 2s2, 2p6, 3s1. Using inert gas, for sodium we'll use neon. So it's neon, 2s1 becomes 3s1. That means it's in the third period. Potassium, using inert gas, we can write argon, 18, 3s1 will become 4s1. Rubidium, the inert gas used is krypton, 5s1. Cesium, the inert gas used is xenon, 6s1. Francium, the inert gas used is radon, 7s1. So this is how we write the electronic configuration of the alkali metals. Next, let us study the ionization enthalpy. Ionization enthalpy. It is also known as ionization energy. It is also known as ionization potential. Now, what is this ionization enthalpy? It is defined as the minimum energy required to remove or take out an electron from the outermost cell of an atom in gaseous state. So let us take lithium. Lithium atomic number is 3, electronic configuration helium 2s1. So there are two cells. So lithium nucleus will be at the center, first cell, second cell. In the first cell you have 2 electrons, in the second cell you have 1 electron. Now here, in case of lithium, this is the outermost cell. This is the electron in the outermost cell. So this electron is also known as valence cell electron or valence electron. Now, the energy which will be required to remove this electron from the outermost cell is known as ionization energy. And the energy will depend on nuclear charge, size. Now, if the size increases, ionization enthalpy decreases. If the nuclear charge increases, ionization enthalpy also increases. Now, let us see this with the help of group 1 elements. So, group 1 elements, lithium, 3, electronic configuration, helium, 2s1, sodium 11, neon, 3s1, potassium 19, argon, 4s1. Similarly for the next element, so we'll first compare the 3 elements, the order will be same. So lithium has got 2 cells. This is the first cell, second cell. This is lithium. Nucleus will be at the center, 2 electrons in the outermost cell, 2 electrons in the first cell, 1 in the outermost cell. Sodium, total number of cells you have 3. So nucleus, first cell, second cell, third cell. Similarly, for potassium, there will be 4 cells. Now, first thing, what is meant by nuclear charge? Now, nuclear charge is the force of attraction between the nucleus and the electron. Now, the nucleus, what it will do, it will try to pull the electron toward itself. This property of the nucleus is known as nuclear charge. Now, if the electron is closer to the nucleus, nuclear charge is more. If the electron moves far away from the nucleus, nuclear charge will decrease. In case of sodium, first cell you have 2 electrons, second cell you have 8 electrons, third cell you have 1 electron. Now, if you compare sodium and lithium, you will need more energy to remove an electron from lithium compared to sodium. The reason being, in lithium, the nucleus is close to the outermost cell compared to sodium, because in case of lithium, you have 2 cells, whereas in case of sodium, you have 3 cells. So the nuclear charge in lithium is more than in sodium. So if you have to pull out an electron from lithium, you will need more energy compared to the sodium. So if you compare the group 1 elements, lithium, sodium, potassium, rubidium, cesium and francium, as we go down, the number of cells will increase. Now, if the number of cells increases, the size increases. If the size increases, nuclear charge decreases, and if the nuclear charge decreases, ionization enthalpy also decreases. So as we go down the group, in the first group, that is from lithium to francium, ionization enthalpy decreases. Now, if you compare along the period, say you have lithium, beryllium, boron, carbon, nitrogen, oxygen. Now, if you move along the period, you'll find the alkali metal, they will have the largest size. So in that case, they will have the minimum nuclear charge. As we move along the period, size decreases, nuclear charge increases, as a result, ionization enthalpy also increases. So along the period, the alkali metal will have the lowest ionization enthalpy. So it's quite clear here. Along the group, the ionization enthalpy decreases down the group due to increase in size and decrease in nuclear charge. Along the period, the ionization enthalpy decreases. That means the alkali metal will have the minimum ionization enthalpy in a group due to maximum size. So in the next video, we'll study atomic and ionic radii.